Hello, this is Judith Gasper, APN 615, Nutrition and Metabolism. Today is August 13, 2017, and I'm here to present my IRB proposal. The purpose of this study is to establish a design that seeks to find further evidence that prenatal vitamin D deficiency associates with child food allergy. The nutrient that we study is vitamin D. It is a unique vitamin. We can take it in from food, as well as it can be produced in our skin with the help of the sun's ultraviolet B light. What this study aims to achieve is to show possible relationship between maternal vitamin D deficiency and child allergy. The tolerable upper limit is 10,000 IU for adults. It may result from excess amount of supplements. Through sunlight exposure, one can never exceed the upper limit. It causes calcium buildup and leads to calcification of soft tissues. Headaches, hypertension, and renal dysfunction are signs of toxicity. Deficiency causes most commonly known rickets in children and osteomalacia in adults. It also causes muscle dysfunction, and it's linked to hypertension, cardiovascular disease, type 2 diabetes, certain cancer, and autoimmune disorder. There are not too many food sources that we can take vitamin D from. They are fatty fish, fish liver oil, and egg yolk. We can produce this vitamin in our skin by the UVB light from 7-dehydrocholesterol. And now I would like to share my findings on literature about vitamin D deficiency and child food allergy. The European Academy of Allergy and Clinical Immunology proposed a classification of allergic disease as follows. Hypersensitivity refers to clinical response to airborne or food contact allergens. Food allergy describes response to food that's digested. And all other responses are under the non-allergic food hypersensitivity category. Food allergy is further classified into type 1, type 2, type 3, and type 4. Our interest in this paper is type 1 allergy, which is IgE-mediated food allergy. Food allergy has tripled in children since the 1990s to today. There are several hypotheses about the causes. However, the pathogenesis remains unknown. It's also called the disease of modern civilization, and there are several factors that play a role in it, such as changing environment, the popularity of cesarean section, extreme hygiene, and changing food consumption. Food allergy is also hereditary. The risk of allergic development of healthy parents is between 5 to 15%. When one parent is allergic, it is about 40%. And when both parents are allergic, it goes up to 60 to 80% that the child may develop allergies. Several disparate factors have been studied in connection with child food allergies, such as microbiota, infant feeding practices, maternal diet, and recently researchers turned to vitamin D, and low level of vitamin D may provide a link to confluence of all these variables. Vitamin D is a unique vitamin. It can be taken in through food, as well as it can be synthesized in the skin. There are two major forms, D2, ergocalciferol, and D3, cholecalciferol. They only differ in their side chain, and they are metabolized the same way. When it enters the body, it is biologically inactive until it goes through enzymatic hydroxylation. The first one happens in the liver, and the end result is 25-hydroxyvitamin D, and the second one in the kidney, producing 125-dehydroxyvitamin D. Low level of vitamin D is common in modern societies, and that is another reason why researchers turn to examining it in connection with food allergies. Due to the need of sunlight for vitamin D production, researchers looked at times of birth and food allergies. They confirmed that infants who were born during the autumn and winter had higher prevalence of food allergies. Another study looked at EpiPen prescription and found that they were more often prescribed in the northern USA than in the southern parts. They also had a Google search study when they looked at search terms such as asthma, allergies, and hives, and they found that they were significant higher numbers in the northern US states than in the southern ones. It has also been proven that vitamin D receptors are receptors to more than just calcitriol. They are located in every cell and tissue of our bodies. Vitamin D deficiency is associated with elevated IgE sensitization in children. Research also showed that the significance of human intestinal microbiota and its role on health and disease, and gut colonization maintains balanced immune response. The maternal intestine colonizes the newborn intestine, and they found that children with allergies had altered gut biota. They also found there are also researches on the contrary, where vitamin D supplementation during lactation showed increased risk of child food allergy. Based on the existing research results, between low level of vitamin D and child food allergy, I propose the following research question. Does prenatal vitamin D deficiency increase the risk of food allergy in children? In this study, the following data will be collected. Self-reported online survey about mothers' food consumption, blood test for serum 25-hydroxyvitamin D levels, which will be done in each trimester once. Based on the vitamin D status level, the categories will be severe deficiency, moderate, mild, and adequate level. Since vitamin D is dependent on sun exposure, recruitment will happen twice, in April and October. April is for January birth and October for July birth. Data on child allergy will also be collected up to age 3. All data will be recorded on secured computers, and the investigators will be responsible for accuracy, completeness, legibility, and timeliness. The population sample will be expectant mothers and their children up to age 3. They will be recruited in the Boston metro area through medical offices of OB/GYNs. Participation will be voluntary, and inclusion criteria will be pregnancy in first trimester and mother has no known food allergy. Data collected will be organized in a contingency table as shown here. Our population sample will be 200, which was determined with the help of G-Power, chi-square, goodness of fit test a priori. The independent variable is mother's serum 25-hydroxyvitamin D level. The dependent variable is children's food allergy. The null hypothesis is there is no relationship between maternal vitamin D deficiency and child food allergy. The alternative hypothesis is there is relationship between maternal vitamin D deficiency and child food allergy. The critical value is 7.81 based on the chi-square test, and degrees of freedom 3. We set alpha at 0.05 at power of 95. If the calculated value will be less than 7.81, then the null hypothesis will be rejected and the alternative hypothesis will be accepted. Subject confidentiality will be strictly held in trust by the investigator and staff. Privacy of subjects will be protected by coding the identity of participants. It is particularly important because subjects are vulnerable, pregnant mothers and children. Bellman principles will be enforced and identifiable data will be destroyed at completion or termination of the study. The first interaction by study coordinator, who is a registered nurse, will happen at the offices of OB/GYNs. The second one will happen at blood tests. Surveys will be online, and there will also be a follow-up meeting with subjects to discuss the results of the survey as well as the lab or blood test results. Written informed consents will be provided to each subject, which will describe the procedures and risks, and subject's signature will be obtained. Risk and benefits to participants. No drug administration or intervention will be part of the study. Therefore, physical and psychological harm is minimal to subjects. The significance of the study is that if we find relationship between low level of prenatal vitamin D and childhood allergy, it will prompt future research. The contribution to the field is that if vitamin D plays a role in the increasing prevalence of food allergy, then correcting prenatal vitamin D deficiency would help reduce the number of children who suffer from this disease. And discoveries hoping to make it would be a step forward to preventing new emerging epidemics. And with that, I conclude my presentation. Here are the references that I used. Thank you very much for your attention, and bye for now.